topic we need to touch on is combining functions. Given the functions f of x equals 2x minus 3 and g of x equals x squared minus 1, find each of these functions and then state its domain. So f plus g of x is the first one we have, and that means exactly what it looks like. We have our f plus our g, or f plus our g, which would be x squared plus 2x minus 4. Now, the domain of any quadratic function in this manner, it's a polynomial really, the domain is all real numbers, so negative infinity to infinity. All right, next we have f minus g. Same idea, different operation. Minus x squared minus 1, which would be negative x squared plus 2x minus 2. And that is f minus g. Now, same idea here. It's a quadratic, so our domain is negative infinity to infinity. You might wonder, if we're always going to get a quadratic, then why are we even worrying with that? Well, there are a couple of places where that will not be the case. So f times g is going to be 2x minus 3 times, where'd my function go? Minus x squared minus 1. So x squared minus 1 there. Okay, multiplying this, we will get a 2x cubed. 2x cubed minus 2x minus 3x squared plus 3, which I'm going to rearrange slightly. 2x cubed minus 3x squared minus 2x plus 3. Our next operation is division. So we'll take our f divided by our g. F divided by our g. Now, what is the domain of this function? Well, the numerator is all real numbers. The denominator, its domain all on its own, is all real numbers. However, we cannot divide by 0. So what values would make this denominator 0? Well, x squared minus 1 equals 0 would give us x equals plus or minus 1. So our domain is x is not equal to negative or positive 1. So I'm going to write our domain in this way: negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. The same way we skipped them previously, except now we have 3 intervals because we're taking those 2 points out. Oh, and I did not write that here. Our domain on this last one was negative infinity to infinity still, but when you're dividing, be very careful about the domain because we end up dividing by 0 most of the time there. All right, example 6. Consider the functions x squared plus 1 and 1 over x. Find g of f of x and state its domain and range. So g of f of x means that I'm evaluating g of x at f of x. So in this case, that would be g of x squared plus 1. Now g is the reciprocal function, so this is 1 over x squared plus 1. So there's our function. There's g of f of x. The denominator here is never 0. It's always positive. So our domain is all real numbers. Okay, now our range, this is a reciprocal function or a rational function. So we have a horizontal asymptote here of 0. So we actually get the y values are everything except 0. This is a function, like I mentioned earlier, that does not have a y-intercept. It doesn't actually... Oh, scratch that. It has a y-intercept. It doesn't have an x-intercept. All right, evaluate g of f of 4 and g of f of negative 1/2. I'm going to go ahead and use my function g of f of x. Go ahead and just write that in here. Equals 1 over x squared plus 1. So evaluating that at 4, I'm just going to write that differently there. Evaluating that at 4, we get 1 over 17. All right, g of f of negative 1/2, because we already know what the function is, now we found g of f of x, we can evaluate that at negative 1/2. So that would be 1 over negative 1/2 squared plus 1, positive 1/4. So that would be 5/4, and that should be 4/5. Find f of g of x. We're going in the opposite direction. So this is f of g of x. G of x is 1 over x. And since f is x squared plus 1, this is 1 over x squared plus 1. We squared 1 over x. The domain of this function is all real numbers except for 0. We can't plug in 0 there. We divide by 0. Now the range, this is going to have a horizontal asymptote at 1 actually. The first part's going to be has a vertical or horizontal asymptote at 0, so we cannot get a range value of 1. All right, now we're going to evaluate that function at 4 and negative 1/2. If we evaluate that at 4, okay, f of g of 4, that would be 1 over 4 squared plus 1, 1/16, so that is 17/16. And if we evaluate that at negative 1/2, okay, we will have 1 over negative 1/2 squared plus 1. That is 5. Squaring that, we get 1/4. Flipping that over, taking the reciprocal, we get 4 plus 1. Okay. Consider these functions. Evaluate f or g of f of 3 and g of f of 0. So this means g of f of 3. Well, f of 3 from here, this table, tells me that's negative 1. Or negative 2. And then g of negative 2 is 0. So my end result there is 0. Now if I want g of f of 0, f of 0 is 4. So that's g of 4, which then is 5. Now we want to state the domain of g of f of x. Well, notice that f of x takes a particular set of numbers. We have negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. Takes those numbers to the values negative 2, 0, 2, and 4. And then g of x takes negative 4, negative 2, 0, 2, 4. Takes those to the values 1, 0, 3, and 5. All right, so the outputs of f are these three. Well, if we only consider those 4 numbers there, 4 outputs as the 4 inputs here, what we actually get is that the domain is that set negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4 But our range ends up being everything except for 1. It doesn't actually get mapped to. Because we're not including this -4, and the -4 actually goes to 1. So only these 3 are part of our range. Next, let's find f of 3. Well, f of 3 is going to -2, and then f of -2, we're just using that same chart again, that goes to 4. Okay. F of 1. F of 1 is -2. So it's f of -2, and then that goes to 4. Again. Okay. State the domain and range of f of x. Okay, again, f maps these numbers here to these. Well, where do these 4 go under this table? -2 goes to 4. Okay, so our output is a 4 there. Okay, so our domain is simple. Our domain is -3, -2, -1, 0, 1, 2, 3, and 4. Our domain, where do those go? Well, again, -2 goes to 4. 0 goes to 4, so no need to put that down again. 2 goes to 0. And 4 goes to 4, which we already have written down there. So our range is actually just as the set 0 and 4. Okay. Store's advertising sale of 20% off all merchandise. Caroline has a coupon that entitles her to an additional 15% off any item, including sale merchandise. If Caroline devises to purchase an item with an original price of X dollars, how much will she end up paying if she applies her coupon to the sale price? Okay. We have a function here. The sale itself, I'm going to call it S of X, is 20% off. So 0.8x, that is the sale price. Now her coupon gives her 15% off, so it's 0.85x. It takes off the cost is now 85% of what it was. So if she applies both, we're actually finding coupon of sale price of X. So that is 0.85 times 0.8x. And if we multiply those two, that is 0.68x. So how much will she end up paying? 68%. She'll end up paying 68% of the price. So she doesn't actually get what you might think she'd get off, but it's multiplying those two.